Hi, and welcome to this presentation on unit conversions specific to different temperature scales. Let's start by describing the difference between heat and temperature. As scientists, we need to be aware of the difference between these two terms in order to truly understand how unit conversions work. Heat is a form of energy and describes the amount of energy in a system. The standard international or SI units of energy are called joules. Temperature is a measure of the amount of average molecular motions in a system and is expressed in alternative scales such as degrees Celsius, Fahrenheit, or Kelvin. The Celsius scale was developed by the Swedish astronomer Anders Celsius. The Celsius scale is based on two important properties of water: its freezing and its boiling points, which are designated at 0 degrees Celsius and 100 degrees Celsius, respectively. The Fahrenheit scale was developed by Daniel Gabriel Fahrenheit. In Fahrenheit scale, 32 degrees is considered the freezing point of water, and 212 degrees is the boiling point. This scientist didn't use water when establishing the temperature scale, but rather determined freezing point based on a mixture of ice, water, and ammonium chloride. If we then use the Fahrenheit scale to see where water freezes, it happens to be at 32 degrees Fahrenheit. The point at which it boils measures 212 degrees Fahrenheit. The Kelvin scale is the standard international unit for temperature measurements. It was proposed by William Thomson, and it is an absolute thermodynamic temperature scale. What does absolute mean? It means that the temperature reading is not followed by a degree symbol, but rather just the unit name, which is Kelvin. The Kelvin scale is based on the lowest possible temperature, where the particles of matter have their least amount of motion, and therefore could not be any colder. In Kelvin scale, the 0 point happens to be 273.15 below that of the Celsius scale, and therefore water's freezing point is 273.15 Kelvin, or 273 K. The boiling point is 373 K, which is 100 degrees higher than 273. When measuring temperature in scientific experiments, either the absolute temperature scale, Kelvin, or the Celsius scale are used. However, it is important to note that the Fahrenheit scale is used in the English system. Because more than one scale might be present in any given formula, you should know how to convert from one to another. So, now that we know about the three temperature scales, let's compare them. In order to do this, we need to start with a standard. The freezing and boiling points of water at sea level are a good starting point for comparison. If you look at the thermometers on the slide, it will become apparent that the freezing and boiling temperatures of water vary depending on which temperature scale is used for the measurement. It is important to note that there are 180 units between the freezing point and boiling points of water in the Fahrenheit scale, 212 to 32, and 100 units before the freezing and boiling points of water in the Celsius scale, 100 to 0. Therefore, the ratio of units between the Fahrenheit and Celsius thermometers is 1.8 to 1. Or 180 to 100. This means that for every 1 degree rise in temperature on the Celsius scale, there is a 1.8 degree rise in the Fahrenheit scale. The formulas to convert between different temperature scales are presented on this slide. You'll notice that no formula is provided for the conversion from Fahrenheit to Kelvin or vice versa. That's because if you need to convert from Fahrenheit to Kelvin or Kelvin to Fahrenheit, the first step would be to convert Fahrenheit to Celsius using the formula provided, and then convert the result in Celsius to Kelvin using the formula provided. Let's practice converting from degrees Fahrenheit to degrees Celsius, and then to Kelvin. If you recall from the conversion formulas, to convert from Fahrenheit to Celsius, we need to subtract 32 degrees and then multiply the result by 5/9. For the body temperature conversion, that will give us a result of 37 degrees Celsius. To convert to Kelvin, we would add 273 to the Celsius results, which will give us 310 Kelvin. Let us pause for a moment so that you can try the second problem on your own. Just the same as the previous example problem, you will subtract 32 from the Fahrenheit temperature provided and then multiply the result by 5/9. That should give you a final result of 20 degrees Celsius. If we add 273 to that result, we obtain 293 Kelvin. Note that we did not use the degree symbol before the Kelvin unit. If you want to practice further, you can try converting the values back to Fahrenheit. Always remember that water freezes at 0 degrees Celsius, 32 degrees Fahrenheit, and 273 Kelvin. And it boils at 100 degrees Celsius, 212 degrees Fahrenheit, and 373 Kelvin. Thank you.